In this video, we're going to cover a completely new different subtopic, which is method of data analysis. If you're writing question 5, how you're doing this or how you're structuring this is defining the problem, write the subtopic, put the 3 things we talked about. If you don't remember them, check out the first video, this video, check it out. It should help you clarify that. The second part is method of data collection. We talked about that again. Then after that, draw a diagram. Also check out the second video that has that. The third part is method of data analysis. So you're going to write the next subtopic, method of data analysis. And under this subtopic for question 1, you must include 3 things. At least, however, there are additional marks that you also get for writing things that will be present under the additional details. So we're going to cover the additional details a little bit later. So the first mark that you're going to get, if you're writing this part, you've started off with method of data analysis, you need to write plot a graph of dash against dash, right? Okay, so the first dash, we're going to talk about it. We need to first understand what is known as linearizing an equation. So to get this mark, you first need to know how to linearize equations. The first mark for plotting a graph, right? That statement that you write. Okay, so let's go through a couple of examples explaining how to do this. So the first one is from Winter 2023, question paper 5.1. So you'll be given an equation. You write the equation itself firstly. So in this one, I'm saying E is equal to P F Q V divided by R. And I'm seeing the relationship between E and F. So linearizing is basically expressing an equation in the form y is equals to mx plus c, right? Y is the dependent variable, m is the gradient, x is the independent variable, and c is the y-intercept. So if a given equation like the one above, you can use linearization to introduce logarithms or natural logarithms to have a better answer. So if I look at that equation, I could introduce log on both sides, or introduce natural logarithms on both sides. So if you've done A2, you've probably done logarithms on both sides. So if I have ln E on one side, that's going to be equal to ln P V f to the power of q divided by r. Now, I don't want you to go and say ln P plus ln V plus ln R plus ln... No. Group everything you don't need and make it one thing. Look at everything you need and make it one thing. So the first laws of logarithms that you should know, must know, is that if you have ln A times B, that's equal to ln A plus ln B. If you have ln A over B, that's equal to ln A minus ln B. If you have ln A to the power of n, that's equal to n log A. If you have ln E, that's just 1, right? Those are basic laws that you should be aware of. Or log A times B, that's equal to log A plus log B, or log A over B, log A minus log B, or log A to the power of n, that's n log A, or log E. In this case, that's a bit different. We don't really say log E. We'll talk about that a little bit later, what we exactly say, right? Or something like that, right? So the whole point is to say, how can I use or convert that equation into the form y is equal to mx plus c, where the independent variable is x and the dependent variable is alone in isolation on one side. So already E is already on one side. That's perfect. Already in isolation. So I can group PV over R as one thing. So ln E will be equal to ln f to the power of q plus, remember now it's multiplication, ln PV over R. And I refuse. Don't separate it too much and say ln P minus this plus this. Just combine everything that needs to be separated as one thing. So now ln E will be equal to Q ln F plus ln PV divided by R. That's essentially the equation that you're going to create. So if you look at this equation, this is Y, this is M, Q is M, and then this is X, plus everything here is C. So now I've expressed this equation in the form y is equal to mx plus c. So what do I tell the examiner? I tell them plot a graph of y against x, right? A y against x. Remember that format. Start with y, then against x. Don't squeeze them up, right? So now what's on the y is ln e. It doesn't have to be plotted graph of e. It can be plotted graph of ln e, for example. So plotted graph of ln e against, you look at x. In this case, x is ln f. So plot a graph of ln e against ln f, and you get 1 mark under method of data analysis. So if you don't say that, you don't get the mark, guys. Right? You don't get the mark, because if you just go on and try to say product graph of this without linearizing first, you don't know the equation that's present, right? If you have to separate variables, do so. If you have to do ABCD, do so until you have an equation that's linearized, right? A second example, you can see over there, I have 2h over z squared is equals to 2m over a plus b times v plus 1 over b. Again, you're thinking to yourself, z, which is the dependent variable in this case, is related to v by the following relationship, and v is actually the independent variable. So I need to leave z on its own, and I need to leave 1 over v, or v on its own. If I look at that equation, I can be like, I have 2h over z squared. I have to leave z squared on its own. Remember, it doesn't have to be z alone. It can be z squared, z cubed. As long as z as a variable is present on one side, that's more than enough, right? So I'm going to have 1 over z squared by dividing everything by 1 over 2h, right? So in that instance, I have 1 over z squared is equals to 1 over 2h multiplied by 2m over abv plus 1 over 2h times 1 over b. Now you have 1 over z squared, 2 and 2 cancel out. You have m over h abv plus 1 over 2hb. And then you put it to the other side. You have 1 over z squared being equal to m over hab multiplied by 1 over v plus 1 over 2hb. So now you can see that 1 over v, sorry, in this case, is the value of x, and m over hab is the gradient, and the rest, 1 over 2hb, is the y-intercept. As simple as that. It doesn't matter how complicated the equation is. Remember, now it can be more about algebraic manipulation. You can be given more complex equations, but the dependent variable should be y. Right, so in the above equation, I can say product graph of 1 over z squared against 1 over f, and I get my 1 mark. And the independent variable should be x. And it doesn't matter the form these variables are in. It can either be 1 over z, anything log z, on its own, that should be fine. That really doesn't matter. Now, in every question, you get also other 2 marks besides that 1 mark for plotting a graph. Now, if you look at or read these questions carefully, you see that they will always say, find a method or state a method to calculate the constants in that example, for example, a and b, right? There'll always be a part that says, describe how your data can be used to calculate a and b. And your goal is to tell them how a and b can be calculated. As simple as that. So, in the above question, for example, if you want to find a and b, you have to rely on the gradient and the y-intercept. You always have to create equations that help you find a and b, and you have to rely on the gradient and the y-intercept. Is it easier to calculate b first if you look in that equation? Because I can easily express it in the form with h and the y-intercept. And how are we going to do that? Well, like I've said, c is 1 over 2hb. So the y-intercept will be equal to 1 over 2hb. So now I can make b the subject of formula, and b will be equal to 1 over 2h times the y-intercept, and I get the first mark. So always make sure that the variable, the constant that you want to measure, is on one side and is expressed in that format. So b will be equal to something else, a will be equal to something else, and so on and so forth. Now we can then calculate the value of a since we know the value of b. So the gradient is m over hab. So a will be equal to m over b times h over gradient, right? That's the first format. You can leave it here and get your mark. If you want to be fancy, you know what b is. You can flip that and substitute b in that equation. Try that on your own. You should arrive at a is equals to m over h times 1 over 2 times the y-intercept times the gradient. That flips, you have 2m times y-intercept over the gradient. But there's an alternative format of expressing a. It doesn't matter as long as you have a is equals to something and b is equals to something, right? So if a question has 2 constants, you likely get all the 3 marks under method of data collection. If it is 1, just tell them how do you get that thing. Usually it's gradient is equals to something else and make that variable the subject of the formula. Or y-intercept is equals to something else and make that something the subject of the formula. And you have your marks, right? So the goal of these questions is basically to explain how the stated constants can be calculated. And the last part, well, it's not really a bonus mark, but it's usually a mark found under additional details only. So I highly recommend, guys, if you're writing your notes, please, which I highly recommend, have a little book and you're jotting down these notes, right? Just say the relationship is valid if the graph is a straight line that passes through the origin. Number one, if there is no y-intercept. So look at that example. T squared 4 pi over GL, the graph of T squared against L has no y-intercept. So the relationship that we're trying to evaluate between T and L is valid if you can draw a straight line graph that has no y-intercept or that passes through the origin, or just say the relationship is valid if it's a straight line that passes through the point 0, comma, then you put the y-intercept. In this case, it's ln PV over R. That's my C. So it's 0, comma, the y-intercept. So the relationship is valid if the graph is a straight line passing through those points, right? And this only applies if, and I repeat, this only applies if there's a y-intercept. So this is an additional mark. In every question paper, I repeat, in every question paper, you will see this mark. The relationship is valid if the graph is a straight line passing through either the origin or through the y-intercept when it's properly stated as a coordinate. So be very mindful of that, guys, and always make sure that you're able to obtain these marks, right? And that should be it. You should have an in-depth analysis of method of data analysis. What's important here? What's important, number one, is understanding how do you structure an equation. Linearizing it, y is equal to mx plus c. There are two kinds of things you need to do. Number one, algebraic manipulation. Just play around with the variables until it's y is equal to mx plus c. If not, you're going to introduce logarithms. Usually applies when you have quantities combined together or your independent variable is raised to some power of a constant you might need to find. And you're going to rely on the law, ln a to the power of n is the same as n log a, right? That's it. That's all you're going to do. And then you're going to write plotted graph of y against x. And y is anything on the one hand side, that's the dependent variable, and x is anything on the right hand side, which is the independent variable, and you tell them plot that graph. The next part is finding the constants that will be present in the equation, giving them expressions that help them find the constants exactly. And the third mark, bonus mark if the question has 2 points, but most instances it's under additional details, is relationship is valid if a graph is a straight line passing through this particular point. If you do that, you will be able to get all the marks, I assure you, and you will be able to get everything that you ever need. I hope this was helpful. And if you're liking this video series so far, please consider subscribing. And if you want access to this document, a free trial is present in my description, and you can be able to access and see what it looks like. And if you like it, you can be able to have it. So thank you guys for watching, and I hope to see you in the next video series, this one, where we'll be talking about safety precautions and how you can be safe when conducting paper 5. Well, how can you phrase it, at least. Thank you guys for watching, and I'll see you in the next one.